Welcome to the Coldworking shop. Since the last video, I've made some improvements to the rotating head for the lap wheel. Now I've got a proper cover for the top of the motor with a connector on it. I've also got stops over here to keep the thing constrained in position, hopefully manage the drift. And I've got one more piece, one more slice of the marine. See if I can get it in the frame here. One more slice to polish up. So let's see how the new equipment works. This will be the first test of this new, hopefully improved equipment. And trying to remember my sequence here. The piece as it came out of hot work is fairly flat, but it's not flat enough to stick to the suction cup. So I need to kind of roughly flatten it out, just get it to stick before I can start. This is my coarsest metal diamond wheel. It's 80 grit and works pretty well for rapid material removal. As I said in previous videos, I try really hard to get the piece as flat as I can using the paddle and the graphite in the hot working in order to minimize the amount of cold working, minimize not only the time it takes, but just the amount of glass that I have to grind away. So I have no doubt that as my technique improves, and who knows, maybe I'll invent another tool, that my hot work pieces will continue to get flatter and smoother, but somehow I suspect that the very, very first time that I stick it onto the suction cup, I'll probably always end up having to do a little bit of cold work. So I'm turning on the vacuum. It appears to be holding very well. For those who didn't see the first video, I've got a vacuum pump down there connected to a water separator to keep the water out of the vacuum pump oil. And then the holding fixture has a little Chinese gear motor and a tooth belt, and it rotates. I've got an indexing head that can be used somewhat like, almost like a faceting machine, except it's only in one axis. So here we go. Got my timer set for 5 minutes. Gonna put my weight on it. This is a 5-pound piece of 1.5 inch square tube filled with lead, and I can just sit back and watch it. It looks like the keeper is working really well. if I was going to be like totally excellent, I would have it oscillate back and forth a little, but that may be a little too ambitious for this simple mechanism. It would require another moving axis. In the previous video, I also had trouble toward the end of the polishing operation. I had a problem with the rotation started to get kind of inconsistent and uneven. Well, I traced it down and troubleshot and figured it out, and the bracket was made incorrectly. It was made with a slightly smaller distance in between centers than it should have been, and after a while the belt started riding up on the flanges of the tooth pulleys, and it started skipping teeth. So I rebuilt the bracket piece with slots in it, adjustment slots, and now the gear motor is correctly adjusted, and the tooth belt has the proper amount of tension, and it rides really nicely. So because of the experience that I gained the first time that I did this, with 2 minutes on a side looking at it and going, nope, not done yet, not done yet, not done yet, my first polishing session, or my first rough grinding session, I should say, the first rough grinding session will be 5 minutes, and I've got a timer going with a beep on it, so I don't actually have to be staring at it to know when the time is up. I also reverse direction, so now the polishing, or the rotating head, the rotating suction cup, is going in the opposite direction, and it seems to me that that's a more correct direction. I'm not really sure it matters, but it definitely seems that way. So yeah, just watch it rotate. The suction cup connected to the vacuum pump works exceptionally well. It holds the piece in place. I haven't had one slip yet. The holding force seems totally sufficient for the operation, and if it isn't, my suction cup fixture has a rim around the outside, so if the vacuum did fail, if the pump failed, if the hose got loose, I'd have at least a secondary way of keeping my piece from going crazy and flying off and breaking itself. So all appears to be well. Got a little bit of a situation where I cut a slot in the bowl to allow other of these rods to make it down a little lower, and that means that some of the cooling water kind of spews out and gets all over the place. I think I'm going to make a little cover for this thing so that when it's not needed, it can be covered. So we're coming up here on the end of the first 5 minutes, and waiting for the timer to go off. Okay, there we go. So let's I think I need a little lubrication on this thing. And similar to the other piece, similar to my other piece, this guy has a little bit of a divot in the center. So I'm gonna have to, next time I do one of these, I'm gonna have to be a little more careful about getting my center to be divot free. The center is a challenging and tricky part of the assembly process because the triangle sections that come together to form the hexagon, the corners are not precisely sharp, and it doesn't come to a precisely sharp point. I do put a stringer in the center, a double layer, usually a color with black surrounding it, little piece of stringer in the center to try to fill up the hole. But still, when I was making these, I didn't pay attention as well as I should have to flattening the center. I was more concentrating on flattening the outside edges, and as a result, I end up with a bit of a divot in the center of the piece, and that just requires more rough grinding. But as I said in the previous video, fortunately, I have the glass to spare. I'm shooting for a final size of 150, 200, that's 150 to 200 thousandths of an inch, slightly bigger than an eighth and slightly less than a quarter. And so I made my initial slices, my triangle marine slices, I made those guys a little over 0.3, a little over a quarter, and that gives me plenty of wiggle room to grind away any surface imperfections, surface scuds, bubbles, divots. Of course, if there's internal bubbles in the marine, well, I'll never grind those out, and I just have to learn to live with them and hopefully improve my marine making process to avoid bubbles. But it's nice to not cut it too close. When I started doing these chip stacks, I did cut it too close. I cut my original slices a little bit over 150 and then put them together, tried to flatten them, started grinding them down, and noticed as I was grinding, wow, this guy sure is getting thin. And of course, back then I was grinding by hand, and it was becoming more and more difficult to grind the thin piece without grinding the end of my finger off. And in the process of doing that, the inspiration struck, and I came up with the idea, well, why not invent a machine to do it? You got a machine shop, you're an inventor, invent a machine. Don't grind off the end of your fingers. And of course, that's why I'm wearing these gloves, so that if I notice that the tip of the glove is missing, well, then I'm doing something wrong and need to pay more careful attention. So, if I wasn't making a video, I could actually walk away and do something else. This is pretty much a totally automated process that I don't need to pay attention to. But since I'm making the video, I gotta stand here and try to come up with informative and amusing things to say to alleviate some of the crushing boredom of cold work. People have asked, hey, you're going to sell these things? And at the moment, I have no plans to put the lap wheel or the indexing head and rotating fixture. I have no plans to offer them for sale, but hey, who knows, maybe someday. As far as lap wheels go, there's other people making them. I'm not really adding that much to the lap wheel world. The rotating head and indexing head are somewhat unique and that might convince me, well, okay, that's worth doing, that's worth producing, because it is, as far as I know, the only one of its kind. Okay, so let's get our lead weight off. Rotate. Ooh. Looking very good. Still has the tiniest bit of divot. Of course, everything I do is an experiment. Everything I do is work in progress. Everything I do is a learning experience. And having been through this, I am certainly going to pay a lot more attention to the center in the next time I stack up a bunch of triangles. The piece of marine that I made in the previous videos in this video series, which is series 2 of my YouTube adventure, I made enough marine for 3 really nice hexagons and 1 maybe possibly almost usable hexagon. It's kind of an end piece, and only the top surface is even reasonable. The bottom surface is trash. And I will probably end up making 3 of my sculptures out of it. I'm also documenting the entire process of making the sculptures. This particular sculpture is going to be a kind of an ambitious bent and machined wood project using a fixture that was custom designed, a bending fixture that was custom designed and machined, and little bit by little bit, as my sculptures evolve, they're going to get more complex, more intricate, and hopefully end up looking nicer. So, you know, it's all about the adventure. It's not about speed, it's not about production, and at the moment it's not about selling them. It's just challenging myself to, what's the coolest thing I can make? And then can I make one cooler? And then can I make one cooler? And who knows? Maybe as the display shelf starts filling up and I run out of places to put them and I give them away to all my friends, well, and maybe I will offer them for sale. I have absolutely no idea how much that I would charge for them, and even if there is a market. But, yeah. Automated cold work. Of course, if I was still drinking beer, I could be sipping a beer. And no, I don't toke while I'm working. And actually, I don't drink. Back when I used to drink, I didn't drink when I was working. There's a time and place for everything, and working with tools, working with machines, working with anything where mistakes can be made is always better sober and well rested. So, using a center feed cooling water for this lap disc, and using a very small water flow, because it needs enough water to clear away the swarf and prevent the surface from overheating. But if you put too much water on, you start getting hydroplaning, especially this is a 3-inch diameter piece. And if there was too much water, you would easily get a really thick water film and get no grinding done at all. So I'm hoping this is 15 minutes, and wow, that's a long time for rough grinding at 80 grit. But hey, at least I didn't have to spend 15 minutes down there by hand. And that oh yeah. Oh yeah. Oh yeah. Ooh yeah. Ooh yeah. Sounds like a line from a Led Zeppelin song. Ooh yeah, ooh yeah. Okay, so now we're going to flip it and verify that yes, it is. The suction cup is working. Get my indexing pin in place. Start my timer. Get my weight in place. The indexing head has the same geometry as the squeezer. So it has indexing positions for 2, 3, 4, and 6 different increments. So when I put on the perpendicular suction cup and put it in the fixture, I can refine and perfect the outer geometry of my hexagons, and coming up in the future, other shapes if I decide to do squares or triangles or who knows, maybe even more ambitious geometric shapes. If the indexing pin is not put in place and I use the perpendicular suction cup, then I can hook up a cordless drill motor and get continuous rotation and make a fairly precise and, more perfect than I could make by eye circular outline for some of my circular pieces. Okay. Actually putting another active axis on the system to get it to oscillate back and forth, that'd be a whole lot of work for probably almost no gain. It would conceivably even out the wear on the diamond disc and make it last a little longer, but boy, I'm certainly in no hurry at the moment to add another moving axis to this thing. I'm also still exploring what is the proper range of grits to use while cold working. As I said in the previous video, I'm very familiar with woodworking and the way that you go through the grades and grits of sandpaper, starting with coarse for a large amount of material removal and then going up in grit finer and finer each time sanding out the scratches from the previous grit. In Coldworking, well, first of all, I can't see the scratches. I don't have, I don't have the sophisticated training that is needed to actually be able to see the scratches. I look at it and I go, oh yeah, it looks smooth. So I'm not sure at the moment. I have 80 grit, 100 grit, 220 grit metal, then 220, 325, and 600 of the resin bond smoothing pads. I don't know if you can see it over there, the colored pads. And then, of course, the last step is the cerium oxide for the final polish. In previous times that I've done this, I go through all 6 of my grits, and I'm thinking, that may not make really good sense. Maybe I don't need to do 80, 100, 220 metal, followed by 220, 325, 600 smoothing. So I'm going to try an experiment here where I go directly from the 80 grit roughing to a 220 polishing. I think they call it a smoothing pad, and see if that works. I've been warned about the metal discs, that the metal discs can have what they call rogue diamonds, which is, one pesky diamond that happens to stick up above all of its little diamond buddies. Yeah, that still needs a little more. And it ends up producing a deeper scratch than you would expect from the grit of the wheel. And of course, I don't have the inspection skill to look at the piece and see, oh, is that a scratch from a rogue diamond? And I don't know what it would take, if it would take special lighting or special magnification, or maybe get an air hose out here to blow the water off. I got the air compressor is right next door, so it'd be real easy to add an air hose out here. But if I could see the scratches and be able to quantify how many they are, how deep they are, then I'd have a lot better idea and be able to optimize the process, so I'm not just guessing. Of course, cold work is slow, and even if it was optimized, I doubt that I'm ever gonna get it to the point where it's super fast and super enjoyable. I don't think anybody likes cold work. I like the results. When these guys get done, boy, are they ever nice. I'm continuing to evolve my camera setup as I perfect my video technique, and I've been watching a lot of YouTube videos lately. I love YouTube. The University of YouTube is just the most amazing thing ever. There's just what seems to be endless quantities of well-informed experts freely sharing their knowledge, and I just love it. It's really the University of YouTube, free online education at pretty much any level you want. And I've been learning about color grading, S-Log, HDR log, and other various different ways of shooting video under challenging lighting conditions. And so as I continue to learn and upgrade my equipment, hopefully I'll be able to make better and better YouTube videos of glassworking. Glassworking is exceptionally difficult to photograph, especially with a video camera, because even with the didymium filter, the cameras that I use almost all have automatic exposure. I don't yet have a completely manual camera, and the camera is trying to even out the scene, but the point at which the torch hits the glass is just so bright that it blows everything out. So, little bit by little bit, I'm learning to make good glassworking videos, and assuming that I manage to perfect it, I'm going to not only be doing my own glasswork, but as soon as travel becomes reasonable again, going to be visiting my glassworking teachers and the better glassworkers that I know and making videos of them. So we're coming up now on 10 minutes to see if the surface can be evened out, and that's kind of surprising that it's looking like 15 minutes aside to get the rough grinding done. Then I'm gonna switch once the sides are flat and uniform. I'm gonna lower my time down to 2 minutes for the next steps. I don't believe that I need 15 minutes on the smoother pads, because all I'm doing is taking out scratches. So coming down to 0, and there we go. Get the weight off. The ergonomics of this system seem to be working out really well. I still have a low spot. It's not in the center this time, it's on the edge. So, yeah, it looks like the grinding will continue. Like I said, I anticipated this in advance when I cut the slices, and so I have plenty of glass to work with. And as I said in a previous video, many things in this process are all related together. One thing follows from another thing. I start out with my core is somewhere around 3 inches long. The squeezer dies are 4 inches, and I think that a 4-inch marine chunk on a punty on a single-ended machine on the Impala is about the largest piece that's actually manageable. Even if I did have 6-inch squeezer dies, I think a 6-inch protrusion unsupported would start getting a little bit out of control on the end. So I start off with a 3-inch core, and as I add pieces to it, squeeze it, add, squeeze, continue, the core grows and grows, and finally ends up roughly around 4 inches long. And then after the triangle is fully constructed and squeezed as well as I can squeeze it into a triangular shape, a uniform smooth triangular shape, then I pull it down to a overall length of 15 inches or so, including the moils on each end, cut it off with diamond shears, put it in my kiln, which is a 12 by 12 kiln that can't really take a bigger piece, even diagonally. So even if I could pull a piece to 20 inches, it wouldn't fit in the kiln, and I certainly don't want to cut it in half in the middle, because that's the sweet spot. That's the part that is the best quality pattern. So I end up with about a 13, 14 inch, 15 inch piece with knuckles and moils, and about 8 inches or so of usable material in the center, which then is cut into workable sized pieces, cut into 6 pieces that are then heated and sized in the squeezer. Even though I do my best to try to pull as accurately as I can, I'm not yet a master puller, and I suspect that even if I was a master puller, the pulling process introduces distortion. The triangle doesn't end up with nice sharp points. It ends up with rounded off points and slightly concave flat sides. So after cutting it into 6 intermediate pieces, I put it in the kiln, put all 6 pieces in the kiln, put them on a handle, put them back in the squeezer, and resize them using fixed size dies to get them as precise as possible using the fixed size dies. Then after they're cooled and removed from the punty, I take them back to the lap wheel, do some very minor touch-up to get them as perfect as I can get them within reason, stick them together in the assembly fixture, put them on a punty, heat them. Of course, put them on the assembly fixture, put them in the kiln, because at this point I don't want to shock these fairly complex assemblies. So put them in the assembly fixture, tie them together with stainless safety wire, put them in the kiln, get the end hot with a hand torch, put it on a punty, in the Inquala, heat it, squeeze it, and then in the case of this design, it's not pulled. It comes off the squeezer and it's done. And actually, that's what I get for trying to talk while working and misremembering. That is not how this was made. That's how other pieces were made, but this piece was made using a different process. So, gonna need one more pass, I'm afraid. I have made other designs using the method that I just misremembered and described, but this piece, after the segments, the roughly 2-inch long segments, are sized, then I mark them with a Sharpie so that I know which piece is which, and then cut them up into the individual slices, and using the marks kind of do like a book match veneer kind of trick to get the patterns to line up on edge. Make a series of border pieces out of flattened color rod, and then put those into the chip stack fixture. How could I have forgotten my chip stack fixture? It's in the previous video. So then put it in the chip stack fixture and chip stack it together, and then cold work. So the other method of taking the 2-inch pieces, putting them into a hexagon, squeezing them, and then slicing the hexagons is a procedure that I used for other designs, not for this design. So, sorry about the confusion. It's sometimes hard to remember this stuff, especially when I'm trying to improvise dialogue or monologue and pay attention and observe and not fall asleep while doing cold work, because boy is this ever boring. Hope my camera batteries survive. I'm outfitting the glassworking studio with fixed camera mounts, so I don't have to use tripods where every camera is on a welded or fabricated in some other way mounting. And then I have, I'm running AC power, which actually is converted to DC power to run the cameras, but the cameras in the glassworking shop will not require having to pay attention to batteries. So, speaking of batteries, I'm going to go check to see. Yeah, I think I'm still okay. The wide shot is being done on a GoPro, and I kind of like a GoPro a little bit, but boy, they have a lot of annoying quirks. And one of them is really short battery life. There's a good chance that as I learn more and perfect my video technique, I may phase out the GoPro or use it for those special occasions when the extreme wide field of view is necessary. None of my other cameras have anywhere near the extreme wide field of view. Boy, that's going to be now 20 minutes plus the other side 35 minutes. Wow, it's a lot of cold work. And I'm not even on the smoothing pad yet. Which of course brings up another point that I've discussed in the past. And that is, should I edit my videos? Should I speed them up? Is anybody going to want to watch a 2-hour video on cold working? And no, this one isn't going to take 2 hours, but just, you know, philosophically, what's the best approach? And when I started doing glass work, and I gotta, let me hold that thought for a moment. Finish the story later. I'm coming up on my time here, and then I'll get back to the philosophical discussion. Yeah, that's going to be good enough. I'm gonna call that good enough. So we'll find out if this is a mistake or not to skip the intermediate metal pad grits and go directly to the smoothing grit. So I'm checking to make sure the piece is in place on the vacuum fixture. It would really suck to have it fall on the concrete now after all this work. So here we go, 220. The 220 smoothing pad, this is the resin bond pad, and also a fairly small water feed. So let's talk about timing. When I was first learning glasswork, I watched a lot of YouTube videos and really didn't notice how much they were sped up and edited. And when I was first learning, I was really concerned about timing, about getting the timing right. how long do you heat before blowing? How long do you heat before a piece of cold glass is ready to work? How long does the overall process take? There's so many different questions, and when I showed my teacher some of the YouTube videos that I had been watching, he knew immediately. He said, dude, it's sped up and edited. And so for those who want to learn, well, how long does this stuff take? How long does cold working take? How long does hot working take? I'm intending to produce videos in real time. Of course, things go wrong, mistakes are made, cameras stop recording, batteries run out, failure occurs, and so even my unedited videos will sometimes be edited, but the intention of the full-length videos is to give the inexperienced student an idea of what the timing looks like. Of course, when this project is finished, assuming that it comes out as good as I think it will, I'm going to make the edited overview for those who want the entire 8 or 9 hour process condensed down into a watchable video, just so you can see, well, what were the steps? How was it done? And for the more experienced glassworker, once they, well, the extremely experienced glassworker can just look at the finished object and know exactly how it was done. But for the kind of intermediate glassworker who can't quite figure it out by looking at the finished object, looking at the edited and sped up overview will give a sequence of, okay, here's the steps. This one, this one, this one, this one. And for the non-glass workers, for somebody who is just curious about, wow, how was that done? I think the edited and sped up version will be the way to go. Of course, I'm being a little bit, I don't know, if I was cautious, if I was being really, really careful, I wouldn't release any of these work in progress until the final thing was done. And that way, if something went wrong in the last step and I ended up in catastrophic unrecoverable failure, then I'd be able to kind of like forget the whole thing even existed. But, I'm fearless, and I don't care if people see my mistakes. So I'm releasing them as they come. I don't know yet if it's going to be a success. I'm hopeful, very optimistic, very much believe that it's going to be a success, but hey, you're following along with me. So coming up, I also kind of misspoke when I said that I'm going to be doing this for 2 minutes. I'm actually doing it for 5 minutes, and I'm doing it for 5 minutes for 2 reasons. First of all, I got going on my rant, I got going yapping and forgot that I had my timer set for 5 minutes. And second of all, 5 minutes probably makes sense on this step. I'll drop down to 2 for the next grit. So okay, coming up on time. Weight off. Piece out. Rotate. And release the vacuum and just see if I can see anything here. Boy, it looks really smooth. It looks super. I see no scratches at all. It looks super smooth. So, gonna flip it over. Restart. Vacuum pump. Verify that yes, in fact, it is secure. Gotta remember to do that every time. So many things to remember. And we continue. Cameras are still running. Diamonds are still polishing. It's a beautiful day in Nevada City, Northern California. And just a little quick digression, since I've got time and pretty much nothing more to say about coldworking, because, hey, it's coldworking, it's boring, what can I say? This video was shot during the pandemic, and it's unfortunate that many people are seriously affected, either people who have to work, people who have lost their jobs, people who get sick, people whose friends or family get sick. I'm actually doing pretty good. I'm semi-retired. I stay home all the time anyway. I work in my shop. I don't go out. So really hasn't affected me very much at all. About the only thing that's affected me is that my glassworking friends and teachers, I haven't been able to visit them and they haven't been able to visit me. But other than that, I'm just staying home, getting it done. Getting a lot more done than I used to get done. So it's interesting that with this combination, it's oscillating on its own, just by magic. And boy, wouldn't that be cool if it would do that on every wheel, on every grit. The gear motor, the tooth belt, working excellently. The missing a tooth problem appears to be solved. The little machine Delrin cover for the motor appears to be working excellently. The stop appears to be working excellently. And the only thing that I can look at and say, nope, needs improvement is getting that hole filled up so I don't get water all over everywhere. The ground is wet, my shoes are wet. I am wearing my apron and my gloves, so somewhat keeping dry, but that's why it's outside. That's why the coldworking shop is not in the inside shop. Well, that, and I don't have enough space in the inside shop. My inside shop, the machine shop, woodworking shop, electronics office, assembly, warehouse, and glassworking shop, the total amount of floor space available is about 2,500 square feet. Of course, it's broken up into a number of smallish rooms. It's not just one area. And we kind of like to park the car in the garage when it's not being used for shop work. And when I first moved into this place, I thought, wow, 2,500 square feet. That's always going to be enough. Well, it isn't. I'm bumping into everything. Every time I add a new machine, every time I change things around, space gets tighter. Okay, next will be the brown pad, the 325 pad. One guy that I work with, one of my teachers, goes directly from saw cut marine section to brown pad 325 and then directly to cerium, and seems to get decent results. Another one of my teachers says, oh no dude, you need 325, 600, and then 1200. Well, I don't have 1200, so that is actually looking really, really good. I'm thinking I'm gonna be happy with this result. So now I'm going to reset the timer, make sure that I haven't done anything stupid with the vacuum. Reset the timer to 2 minutes for brown pad. Brown 325 pad. Now, these are not new pads. These pads have done quite a few cycles, and I don't yet have a really good feeling for, do the pads degrade over time? Should I increase my grinding and polishing time as the pads get older? Should I be keeping a log of the total number of hours on each pad? And who knows? Lots and lots of things to learn. Learning glass work, learning hot work, learning cold work, learning video technique, learning machining. So many things to learn, which is what makes the adventure fun. And I intentionally use that word. It's never been about the money. Always been about the adventure. So 2 minutes goes a little bit faster. And hopefully, when this process is finished, I'll have a third polished unit. The first one I polished by hand and didn't show it on the video. It came out good, came out nice. The second one was in the video, the previous video with the earlier version of the rotating head. And oh, well that was, oh man. Talking and not paying attention, didn't put the weight on. Probably got almost no polishing done on that cycle, so should I edit that out? Should I edit out my mistake and make it look like I'm perfect? Nah. And speaking of editing, I just discovered a piece of free software from Blackmagic Design, which is absolutely unbelievable. It's called Davinci Resolve, and it's amazing. It's a full-featured professional video editor with an amazingly powerful range of tools, and it's free. Up until I got that, I had been struggling with the various different El Cheapo consumer video editors, and it seems like, well, what are consumer video editors? They're for people who have one camera and they want to add, you know, way too many wipes and dissolves and all sorts of flashy effects and titles and smiley faces and all that stuff. And their support for multi-camera editing is piss poor at best. And I've been fighting it. Their support for audio is piss poor at best. And I've been fighting these editors. I've gone through 3 so far in my quest for making and learning video, and just recently got Davinci Resolve, and wow, what a piece of software. Absolutely astounding. So still seeing the little blinking light over there on the camera, so I may actually be able to finish this video on the battery I have. So, coming out, rotate, power off, verify that I'm still firmly held in place. It's okay to forget the weight, but boy, if I ever forgot to do the vacuum pump, I would not be a happy guy. So yeah, running out of things to say, running out of things to fill the space with. Kind of like they say in the radio business back when there used to be real disc jockeys. You don't want dead air. You don't want that VU meter needle, back when they had needles. You don't want that needle ever sitting on the stop. You always want it moving. So for years, in my still photography, I've been shooting RAW and processing either at the beginning in Photoshop and now in a program called DxO Optics, or I think it's called Photo something, Pro Photo or something like that. Photo Pro, I don't remember. But when shooting stills in RAW, you have a tremendous amount of control in post-processing about how your photo looks, and you can take a poorly lit photo, maybe backlit, maybe too much dynamic range, maybe have some other problems, and you can make it look really, really good with raw processing at them. Oh, and there I did it again. You know, I need somebody standing next to me going, pay attention, dude. Get all your steps right. So in video, I pretty much just take the video the way it comes off the camera. And for this scene, for example, even though I have lighting in the cold shop, the backlight, the sky in my background is too bright. And so I'm somewhat in shadow. In the more powerful video editors and more powerful video cameras, there's a variety of different HDR techniques, log techniques, various different S-Log2, S-Log3, I forget what some of the other acronyms are, but there are a bunch of different 3-letter acronyms that are used to allow more dynamic range to be captured by the video camera. Of course, you can actually shoot video raw, but the file size is just horrendous beyond belief, and just the file transfer time and the demands on the editing system are just absurd. And so hopefully, if I upgrade my camera and learn how to use these various different log curves, I can get a little bit better quality out of my video. And of course, it's all part of the adventure. Learning to make video is every bit as much of the adventure as learning to do glass and learning to improve my metalworking and woodworking. Although I've been doing woodworking for almost 60 years, so I kind of know what I'm doing. On to 600 grit. Don't forget to put the weight on. Okay. Got a new bottle of cerium. Got my disc a spinning. All is well. Probably should make a little sheet metal guard for this thing so I don't get my fingers stuck in the belt, but that's how prototype development goes. You do the first one just to see, does the idea work at all? And then if it works, perfect it. The Inquala went through 10 prototypes before the 11th one was released to beta testers, and the 12th version was the first one offered for sale, and then the 13th version was the first one that I actually consider to be really good, version 2, and I did offer all version 1 owners a free upgrade to version 2. And at the moment, almost everybody has done that. I think there's still 2 of the version 1s out there somewhere where the owner says, oh yeah, I'll ship it to you. It's coming this week. And then it never shows up. So I guess they're probably happy enough with it as version 1. But it's all an ongoing process of continuous improvement. Never good enough. There's always improvement to be made. Of course, that being said, there's also a trade-off when, yes, it's theoretically possible to continue improving forever, but is it worth it? Sometimes good enough really is good enough. Sometimes attempting to go for the impossible goal of perfection, and perfection of course is impossible, because, and this is not just true for me, I think it's true for everybody, as your ability to do things improves, your ability to criticize improves faster. The best musicians I've ever known are critical of their work. The best glassworkers I've ever known are critical of their work. I'm critical of everything I've ever done over 60 years of craftsmanship and engineering. Perfection is a great goal, but it's unobtainable. There will always be some little thing that you can look at and say, yeah, I don't know. That little thing that nobody else sees, that only I can see, and then only if I look really hard. Yeah, that isn't quite perfect. So, you know, always a trade-off. How far do I take it? And of course, I'm not shy about throwing away work. I've thrown away entire batches of Inquala parts where a mistake was made. If I was a total mercenary and didn't want to spend the money or the time on remaking the parts and just thought, yeah, I can get by, I probably could have shipped it and nobody would ever know, but I'd know. So, yeah. I've scrapped entire batches of Inquala parts because, no, they're not up to my standard. Not good enough. And that is the last of the diamonds. And then comes the cerium, and yep. Get the right balance here. The cerium can be cerium definitely has more friction, and it's a question of how much water do I use, how wet should it be. I know that in the cerium step, you don't want it to be too wet, and you don't want it to be too dry, and definitely getting oscillation back and forth. The first time I ever did cerium on this suction cup system, I was kind of somewhat concerned. I was really happy to know that I had that nice lip around the suction cup, because I know how much friction the cerium has on the glass, and certainly didn't want it to grab my piece and fling it away, especially in the last step. But it appears that I'm getting a nice oscillation, which is somewhat surprising. Pleasantly surprising, but still surprising. Looks like I still have a red light on my camera, so I may actually be able to complete this extremely boring coldworking video. Yeah, I'm doing, I reset the timer to 5 minutes. Gonna see what 5 minutes on cerium looks like. I know that typically you go a little longer on cerium. In fact, I've read instruction guides that say the cerium step takes as long as all of the diamond steps combined. And I'm going to do 5 minutes and then see if I can look at it and determine, hey, is that shiny enough? My cerium wheel is a little bit off center, which is causing the whole apparatus to vibrate a little bit, but you know, things are under control. Nothing is failing. The system appears to be working exceptionally well, which is really amazing for, this is effectively the first prototype with modifications, so it's actually not quite the second prototype, kind of like the version 1.5, and the lap wheel is purely version 1. First prototype, worked out of the box, or out of the shop. There was no box. The indexing head, first prototype. Rotating head, slight modification. Of course, another thing that I don't know yet, am I wasting cerium? You have to keep putting it on? Should I be putting more on? That's my air compressor. I put the air compressor outside so that I wouldn't have to listen to it when I was in the metal shop, but now it's right next to me, outside in the coldworking shop. And coming up on 5 minutes of cerium. So, oh, that thickness looks really good. If I had to eyeball it, I would say it's about 180. So almost exactly halfway in between 150 and 200. And thinking it's looking good, but I'm going to give it 5 more minutes of mind-numbing boredom. But at least I'm not doing it by hand. My least favorite thing, cold working. And just in general, I'm a tool user. a proud tool user. I don't consider tools to be cheating. I'm a tool user and proud of it. And for those who, especially a lot of woodworkers, take pride in producing really beautiful and elaborate projects using only hand tools, and to them I say, good for you. You know, that's what you love, go ahead and do it. For me, I'm a tool user. Tool user, tool inventor, tool builder. I love tools. And of course, to the purists who say, oh no, I'm not going to use a belt sander, I'm going to use a hand sander. I'm going to use a hand plane, I'm going to use a hand saw. Well, you know, they're tools too. And it really all depends on where do you draw the line. I use CNC a lot and fully believe that my CNC made work is every bit as artistic as handwork. It's the product of a creative human mind. It's just the tool that I use happens to be a CNC machine. The machine didn't come up with the design. It's not the work, it's not the complete work of a robot. It's my design from my mind, my creativity that just happened to be realized by a machine. Musician playing a piano. Piano is a very elaborate tool, very elaborate machine. Somebody spent many hours, many years perfecting that machine, making it work as well as it does. But the music is the product of a mind. And of course, when I make music, because I've never learned to play keyboards and still have ideas for music, I do it on the computer sequencer, on the digital audio workstation. And I would argue, you know, it does. I'm the first to admit that it's missing something. It doesn't have the magic of human players, but it's still the creative work of a human mind. So I defend it while also realizing its limitations. So one more round of cerium and see if the camera light is still blinking. Yeah. I think I'll be able to finish this entire mind-numbingly boring video. It's interesting that the cerium pad is producing an excellent oscillation. If all my pads produced an oscillation like that, I'd be happy. Of course, I'm happy with it the way it is. It looks like it works perfectly. It looks like it works completely excellently. It looks like I think I can call this design a success. And move on to the next challenge. Move on to the next stage of the adventure. Everyone a little more ambitious, a little more complex, a little more difficult than the one before it. I'm not getting any water in my water trap. I really ended up in trouble on one of my previous pieces. I was polishing one of my much less successful marine pieces that was all full of holes. It was like Swiss cheese. And instead of throwing it away, I thought, well, I'll just polish it up and keep it for its history. And didn't have the water separator on. And sure enough, pretty soon out of the top of the vacuum pump started to emerge a really kind of disgusting oil and water foam. All over the ground, all over the water, all over the vacuum pump. And that taught me marine can have holes in it. Even though my suction cup fits well and my plumbing is all bubble tight, marine can have holes in it. So now I got the water trap. Haven't gotten any water in it yet, so looks like this piece, or these 2 or 3 pieces that I've made with this setup, it's reasonably solid. So yeah, final cerium polishing, and then the next step will be to put the piece on the perpendicular suction cup and use the indexing head to perfect the outside hexagon form. Now, checking the camera. Now this is a somewhat challenging balancing act, because even though the triangles were squeezed in fixed size squeezing dies as accurately as I could do them, and then the chips were assembled in the chip stack assembly fixture reasonably accurately, it is glass, it is hot glass, and the final hexagon is not perfect. And so this fixture with the indexing head, it's not quite a machine tool, but it's way more precise. It was made on machine tools, and it's way more precise than the glass hexagon. So I have to kind of split the difference and use my artistic judgment and make the best hexagon I can make for the outside, while making the inside hexagon look like it actually works together. So round and round and round it goes. I think the telescope makers actually spend a lot more time. I think it takes months of polishing, maybe even longer, to make a telescope. Oh, getting tired of standing up. doing this step for 10 minutes, 10 minutes each side on cerium, and hopefully that will be all I need. Here's another advantage to having a shop that I was able to, in just a few hours, maybe not even a few hours, maybe just minutes, whip up a very nice and usable holder for my diamond discs. I've always been a strong believer in making my own tools. Making things, fixing things, having the power over things. So in most cases, I don't have to wait for some other designer to design something and build it. I just build it myself. I don't have to wait for the service technician to come out. I fix it myself. And in those rare cases, when I don't have the knowledge, the skill, the equipment, and I'm forced to hire a repair technician, well, I watch them really carefully because, hey, now I can learn something. So, coming up on the end of the process here. And eventually, of course, when the sculpture is complete, assuming that it actually comes out as successful as I believe it will come out, I'm going to take really, really nice studio still photos with a proper background and proper lighting and proper post-processing. In this video, I'm just going to kind of hold up the piece to the camera, and hopefully, if I'm lucky, I'll get the light on it so you can get at least an idea what the piece is going to look like when it's finished. So, 2 minutes, and vacuum pump is happy, lap wheel is happy. A little more cerium on there. So when this process is done, I'm going to turn off the camera, take a break, go get a snack, check my email, and then when I come back, I'll be using the perpendicular suction cup and the indexing head to perfect the hexagon shapes. So, coming up on the last few seconds. And that concludes the polishing operation. So, I think it's looking pretty good. I can get some light on it. And thickness looks just about perfect. You can probably see what I mean about the unevenness of the outer borders, but they're mostly correct. And I think I'll have a pretty easy time perfecting the hexagons. So, see you when I get back. So, getting back to cold working again after a short break. Gonna disconnect the power and the vacuum line. This connection between the indexing head and the rotating piece is a standard ER20 collet. Let me get my gloves on. This is the same collet that I use on the Tormach and the CNC router. Here it is right here. It's a standard collet. And then I'm going to put in the perpendicular head. And potentially I'm going to need to change an adjustment here. This travel stop is the first prototype, of course, and like all first prototypes, looks like it might need just a little bit of adjustment. Either that or it'll just barely work, but I think there's going to be some adjustment that needs to be done here. But I also believe that I'm going to be able to accomplish the work. So I'm going to start out here with good old magnets. There we go. I'm going to start out here with the 220 grit, and this is the trickiest part of this process, is trying to line up and get some water on the O-ring and water on the glass piece. And give that a try. Just starting off taking a little bit. I don't think I like that at all. Just a matter of successive refinement. And I just rotate just a little bit. Then lock down the collet. It's possible I continue to be imagining if there's a better way of doing this alignment. Possibly some sort of way of putting on an overlay or something, visualizing what it's going to look like. And that piece is definitely the worst of the sides. And as I try to figure out how to split the difference, I'm gonna have to deal with another thing that I have to be really careful of here. I don't have a swivel joint where the vacuum hose connects. And so as I'm indexing the head around, I have to constantly be aware that I'm not loosening the fitting, because if I loosen the fitting, well, then the part's going to fall off, and if the part falls off, that's really bad news. I wouldn't be happy if the part fell off. So I'm tending to rotate in a direction that tightens the... Yeah, this hex definitely has a bit of a problem. Of course, as I'm attempting to create a nice hexagonal outline, I'm also somewhat considering the possibility of, well, does it really need to be a perfect hexagon? And let me because it's fitting into a sculpture base, I kind of want the overall outer portion to be geometrically correct. And I believe that I will be able to come up with a reasonable compromise that will accomplish most of what I want to accomplish. This is the one bad side. The corner right there is a little off. But hey, the way I look at it, the next one will be better. And the one after that, and the one after that. A process of continual improvement. I probably will eventually end up with a rotary joint on the connection here. It's just far too easy. To let it get out of control. So I'm not going to polish the outside with cerium. I'm just going to give it a quick hit with 600. The outside doesn't need to be polished to a perfect shine. And if it does, I can, if I change my mind, I can always come back. But at the moment, I think the outer edge will be just fine at 600. I'm getting a lot of confidence. Notice that I'm not backstopping the part and just relying on the suction cup. I'm developing a lot of confidence in the suction. Appears to be working exceptionally well. Of course, this polishing attachment could be expanded into a full faceting head if I ever had the inclination to do any faceting work. At the moment, it's not in my plans, but I think it's pretty obvious that the design could be expanded to produce a full faceting head. Now I'm just gonna barely knock off some sharp corners. I want them sharp, but I don't want them razor sharp. And that completes today's work. If you can see that on the camera. So, thank you for watching. It's been fun.